this video, we will solve GATE Physics 2014 question number 48. A particle is confined to a one-dimensional potential box with the potential Vx equal to 0 for x in between 0 to a and infinity otherwise. If the particle is subjected to a perturbation within the box W equal to beta x, where beta is a small constant, the first order correction to the ground state energy is. So this is a time independent perturbation theory problem, related problem. So let's solve this. So the potential this is the one-dimensional infinite potential well. So Vx is 0 for 0 to a and infinity otherwise. So this one is Vx, this is x. Now the perturbation is given as W equal to beta x. So we need to calculate the first order correction to the ground state energy. Now the unperturbed eigenstate for infinite potential well is root over 2 by a sine pi x by a. Then the first order correction will be to the ground state is psi w psi. So it will be 2 by a sine square pi x by a, and x is perturbation dx from 0 to a. So it will be 2 by a x, sorry, it will be 1 by a x 1 minus cos 2 pi x by a, because 2 sine square pi x by a is 1 minus cos 2 pi x by a. There was a beta, because w equal to beta x, so beta is also there, which is independent of x. So beta by a x dx minus x cos 2 pi x by a dx. Limit is from 0 to a, 0 to a, 0 to a. So beta by a x square by 2, 0 to a minus. So this is x a by 2 pi sine 2 pi x by a, 0 to a minus, this will be plus integration from 0 to a by 2 pi sine 2 pi x by a dx. So if we use the limits, then it will be a square by 2 minus, now sine 2 pi is 0 and 0 0, this will go to 0, and here we get a by 2 pi whole square, 1 minus sign will come out, so this minus will minus cos 2 pi x by a from 0 to a. So beta a by a into a square by 2 minus beta by a into a by 2 pi whole square, and this is cos 2 pi minus cos 0. So this will go to 0 and we will have beta a by 2. So this is the correction to the first order energy, to the ground state energy. So option C is correct. So option C is correct. Thank you.